Alright, welcome back everyone. Now, what we should have by now is, should have the lab report downloaded, saved to your computer, your name on here and everything. And you should have a list of all of the different levels from the Vishnu schist all the way up to the Redwall limestone. You should also have filled in the gaps in between the different layers wherever you can, based on how you know that the different rock levels are formed. So as we go from schist, which is formed by pressure, to the Zoroaster granite, which is intruded, we know that the only way to get intrusion is that magma enters. When exactly that happened, we don't know, but at some point it did, so we might as well put it up here. We know that to go from granite to get limestone, we must have had water. A shallow sea must have formed. And to go from limestone to getting shale, what must have happened is that the water level must have risen, giving us a deep sea to get shale. And what we'll find is that we can fill in a lot of these gaps by mostly saying that the water level rose or fell. But some of them are basically the same thing. For example, quartzite, if you look at the diagram, you'll see that the way they show quartzite and the way they show sandstone, they look identical. And the thing is that quartzite is, used to be sandstone, but it's been changed by a little bit more pressure, I think. That's basically the difference. So, for all practical purposes, for this lab, we'll just say that they're the same thing. Quartzite is sandstone. End of story. We don't need to detail it anymore. Since they're deposited in the same place in a beach, well, what must have happened in between them? That's a problem. We need to fill that in. We also have the same thing when we have limestone, limestone, and then limestone again. Well, what do we put in between? Well, here's where we have to take a look at the lines in between these levels. So let's look between the Chinoomo quartzite and the Docks sandstone, both of which are formed in the same environment, and let's see what we can find. Okay, here's the Chinoomo quartzite and the Docks sandstone. Same kind of thing, but look at what's really obvious. All of a sudden, this tilt of the lines at the top, they were not level until we get up to here, and then all of a sudden we can see that it goes flat again. So at some point after we had added the Vishnu schist, the Bass limestone, the Hakatar shale, and the Chinoomo quartzite, the whole thing, the whole structure was tilted somehow. That's what happened in between the Chinoomo quartzite and the Docks sandstone. Some sort of tilting of the earth. So let's write that down. Tilting of the, it's not the entire earth or anything. We'll say the rock. Some sort of tilting. And if we look at our lessons, let's see if I can find that. I think it was 404. Let me pause the video and come back once I've found it. Okay, so lesson 404, page 5, it shows you these different unconformities. And if we look at this section right here, we've got this angular line. It's tilted, it's not flat. And let me read to you what it says. Angular unconformity. Notice how the layers of rock on the bottom are at an angle and the ones above are horizontal. Something must have changed to cause the difference. So some sort of plate movement tilted these layers is what most likely happened. Alright, so we've got that in our lab report. The tilting of the rock, we'll say layers. Okay, so then we're still in the same place. We're still on the beach, so we're still forming sandstone. Nothing has to change until we get to the mauve limestone. And then Temple Butte limestone, or I'm not sure how you pronounce that. Is that Butte? Is that Butte? I think it's Butte. But anyway, What's happening in between those? It's both limestones. Let's take a look. Mauve and Temple Butte. Okay, here's the line between them. See that? See how it's not flat? It's jagged up and down. That tells us there was erosion. Something caused erosion. We don't know what. But let's just write down erosion. There's enough erosion that it left all these bumps and hills for the next layer, the Temple Butte limestone. We can see that erosion caused that line in between the layers. Okay, so what's in between the Temple Butte and the red wall limestone? Let's go take a look. Temple Butte, red wall. Oh boy, there's another jagged line. Same exact thing is happening. Erosion. So let's write down erosion. Alright, I'm going to leave the very last one for you. What happens right after the red wall limestone is deposited? Let's take a look at it together. At the red wall limestone, I can see by the way they fill it in that this Wadahoming formation is limestone also. But this line, what causes this jagged up and down line? Answer that for me. That's the answer to the very last thing that you need to put. Okay, so let's look over what we have so far. I'm going to leave the last one blank for you to fill in. Make sure you fill that in. We've dealt with how the rocks are formed, and we've dealt with the transition from one rock to another. Let's just take a look at the image and make sure that we got everything. Okay, so we started here. Did we say how that was formed? We should have. How about the Zoroaster granite? Did we say how that was formed? I think we did. Base limestone, we say how that was formed. Hakatar shale, we've got how that was formed. Shinomo quartzite, I think we put down how that was formed. And then you see how the whole thing is tilted, the whole bottom part is tilted. We better explain how that happened. That should be in there. Okay, so do we explain how we go from this quartzite to the sandstone? And then do we explain the limestone? Oh, you know what, kids? Looking at this T-Pete's limestone, look at how they fill it in. It doesn't look like the limestone up here, does it? It looks just like the quartzite and the sandstone. T-Pete's, maybe this is a typo here. Let's go to our good old friend Google, Mr. Google, and let's look up T-Pete's. I'll do it here in Wikipedia. This I found this article on quartzite in Wikipedia. Quartzite is a hard, non-foliated, metamorphic rock. So it formed through some pressure, which was originally sandstone. With that in mind, you know what? Wherever it says quartzite, let's put that there is some pressure there. Just to be really thorough. Where's the quartzite? So right before a quartzite, we'll say pressure. We don't know when this pressure happened though. It didn't happen right before it was deposited. So yeah, let's leave the pressure out. At some point it was pushed together though. At some point. We don't know when it was. We could even put that last. Pressure turned sandstone into quartzite. Let's put it last. Oh, I left that blank, so I need to put something there. Pressure turned sandstone into quartzite. There we go. No, you fill in that space. I left that empty because I'm just so hard on you kids. Okay, back to Wikipedia. So we were going to look up T-Pete's, right? T-Pete's. Does it have it? Do you know what that is? I'm thinking that this is a typo and it should be T. Pete's sandstone. Wikipedia doesn't have it. So I'll Google this sucker. Oh, look at that. It does have it. T. Pete's sandstone. So T. Pete should be sandstone, and they got it wrong. This changes some things. If the T. Pete's is sandstone and not limestone, then the weather conditions really didn't change between the Dock sandstone and the T. Pete's sandstone. So let's go up and let's fix that. Where is the Dock sandstone? Here's the Dock sandstone. And we say the water level rose so that we could form limestone. But it's not limestone, it's sandstone. Let's put that there. And what's the difference between the Dock sandstone and the T. Pete's sandstone? Take a look. Well, it looks like a pretty jagged line to me, and I think you know what that means. So fill that in. Fill in that blank for me. What happens in between the Dock sandstone and the T. Pete's limestone? Just out of curiosity, let's see if there is a T. Pete's limestone. Well, there's Tapeats limestone. That's not what we're looking for. No, it's not. Okay, so T. Pete's is sandstone. Very strange mistake to find. Okay, what do we have to do now? Oh, we're going through our checklist, making sure we got everything. Alright, we were up to the T. Pete's limestone. Do we explain how we got to shale after that? Look through your work and make sure we did. Do we explain how we got to mauve limestone? Do we explain why there's a difference between the mauve limestone and the Temple Butte limestone, and the Temple Butte and the Red Wall limestone? And do we explain what caused this jagged line up here? If we've gone through all of that, I think we've told the whole story. So that means I think we're pretty much done with that assignment. At least with that first part. So what I'm going to do is I'm going to stop the video, give you some time to look over your answers, make sure that you've covered the whole story, and that you filled in those blanks that I left, and then we'll continue with the next question. Just so you know, you have this box for the score to make sure that everything's in the correct order from bottom to top, and we also have this score that says that you put in the proper environmental changes. So as long as you have both of those correct, you'll get full points. Plus there are these points that are kind of like bonus points, attention to detail and completeness. I don't know how to grade those, so you know, as long as your work looks pretty good to me, I'm going to give you full points for that. Oh, I guess we were supposed to put this whole answer down here at the bottom under answer. Oh well, let's cut and paste. Ah, darn you. Okay. Blah blah. I'm not gonna mind if you have it up where it was before or anything. Okay. Alright, doesn't quite look right, but that's cool. No, I'm giving the answer away. Okay. There we go. So, let me stop the video and start a new one where I deal with question 2.